Right, further to this drive problem. On the 2020 a strange fault has developed whilst I've been finding the drive fault. And the best way I can show it to you is give you all the symptoms and see how we go from there. We're going to transmit without any drives, so I've got two-tone feeding in here. And here the receiver on 40 metres at the moment. So if I go to manually transmit there, you can see the idle current, and there's two arrow tips between 0 and 100 on the milliamp scale. So we're at the first one, which I suppose is around 30 milliamps, and I can show you if I adjust the bias pot at the back, providing I can get the screwdriver in the slot. There's the plate current meter moving there. So I'll put it back on the arrow. So that shows that it's drawing idling plate current correctly. Now I haven't changed anything in the transceiver since the last video, but now when I bring up the drive level, if you have a look on the crow, I'll put the light out, this is on 40 metres, two-tone signal, the intensity up a bit for you, bring the drive up and up, it's starting to distort there. Well, the strange thing now is that it's developing ALC. There's a bit of crossover distortion there, but say there. And if I hit the down here, the switch for ALC, and I increase the drive beyond that, lo and behold, the meter comes up. I wasn't actually doing that before. And on the waveform on the crow, you can see that it's starting to distort at the top. So the ALC is doing what it's supposed to do, but I haven't done anything. So that's all good. But you'll notice that when it does that, the plate current is still only just above idling. So there's 60 milliamps. So right, 60 milliamps of plate current. It's not quite into distortion. So look at the waveform up there, that we can peak the drive like so, and then we can peak the output by dipping the plate, which peak the output, but didn't do that before. This is even changing further. Alright, so I'm now able to adjust the load control correctly. So this is the peaking of the drive, the dipping of the plate, which is the same as peaking the output, and now I'm adjusting the load control. But if you look on the meter down here, which I can face your way, that's 10 watts down here. It's only just making 10 watts, especially if I drive it a bit harder. And it was nearly 50 watts before, it was at least 40. So that's peaking the output. So that's peaking everything. It's barely making 10 watts. And we can draw a grid current, as you saw the ALC. So I can't drive the grid any higher, and I've checked the bias is correct, I've checked the drive is correct, I've checked the screen voltage, and I've checked the plate voltage. And it's almost running, except not quite, because we've had this drop in output. And as all the tuning controls seem to be working correctly, as you can see here, there's the drive, which is the pre-select right in the centre. The plate's dipping there, but it's a very small dip. And that's the loading, which hardly affects the plate current at all. So you can just go past the peak with the loading. If I go to another frequency, say that's 40 metres, go down to 80, drop the control for the tuning there, hit transmit again, peak everything up, there's peaking the drive, peaking the plate. The loading I can never seem to get optimum on 80 at the moment, and bring the drive up again until we run out of, it's between 5 and 10 watts, so the output's dropped considerably. It's only pulling 60 milliamps and showing, you know, about a sixth of what the output should be. So something's changed, and I don't really know what it is at this stage. If it was something to do with the components in the tuning network on the output, I would think that I wouldn't be able to dip the plate and peak the loading, but I can, mind you, not very well, except on 40 metres. Let's try 20 metres. So transmit again, peak the drive, well yes, I can't optimise the loading there. If you look at the Crow, she's flat topping quite a bit there. If I back the drive off, that's back in the linear portion. Yeah, so bring it up again a bit. It's barely making 5 watts on 20 metres. So something's changed negatively and I haven't really done anything. So some component or joint's changed of its own accord. So I'll have to chase that up, but definitely the drive circuitry was not peaked correctly. Certainly on 80 metres it was way out, and it wasn't too good on 20 either. 40 wasn't too bad, so if we can figure out what's going wrong, we'll probably be very close to fixing it. Here's a still shot of the 8552 final that was causing the problem in the 2020. As you can see, the plate cap's removed, and I didn't remove it. It had come off itself. The 8552s are the same as 6883Bs, which are the 12.6 volt version of the 6146B. As I'd been explaining, I was having some problems with output power, so I started to investigate the final section of the transceiver, and whilst looking through the plate circuit and tuning components, I noticed that the plate cap on this 8552 was vibrating a bit, tapping the lead going to it. It was moving around quite a bit, but the lead on the other 8552 was quite okay. So I thought, now that's strange. And then where the parasitic suppressor comes off on the plate lead there, I lifted that up a little bit and the whole thing just came up in the air. I thought, aha! So I removed the 8552 and resoldered that plate cap back on the plate, put it back in, and lo and behold, off it went. Amazing. So it was a hard fault to see because it was a mechanical fault causing an electronic fault, not just an electronic fault, and as the weight of the parasitic suppressor on the plate coupling to the output choke and then the tank circuit, as the weight of all that was sufficient, it still looked like it was quite nicely connected to the valve. And you couldn't actually check the continuity of that because you'd have to be able to get to the plate into the valve, of the valve. So anyway, that is a good trap for young players there. I've come to readjust the bias on the transceiver, and there's a bit of a story in that as well. And also I've been looking at the drive level for the different bands. This is going back to the local oscillators. This local oscillator board on the side here has got adjustments for the crystal oscillators themselves down here. There's a whole stack of crystals for the different bands, and then they're mixed so that for each band we have 3 adjustments, 1 here and 2 here, so that you can peak up the drive level from the local oscillator section on each band. So I've been doing that, and in the process I found that this connector here did have some loose, well, not loose contacts, maybe bad contacts would be the more accurate term, and as a result I took the connector off again, cleaned the contacts with some contact cleaning fluid, and exercised the connector a bit to get rid of any oxidization, and then put it back on again. Further back here, I just had to lift the camera up a bit, we have the underside of the PA section, and I've been checking the bias level here, and I've adjusted the bias to negative 50 volts on transmit, which is I think 83.5 on receive when it's in standby. And the plate current, I'll talk about that when I put the transceiver back together and put it up the right way. There's a weak signal in the background at the moment on 40 meters, but I'll let you have a listen to it on 80 meters later on, I think, and show it in operation. And I'll talk about the idling current then, because I've got a bit of an issue as to the way they say that it should be set. Suffice to say too that any drive levels have got to exceed whatever the bias is in order to develop ALC, and if the bias is too high they'll never ever get there. It's got to drive the transceiver into or the output tubes into positive voltage on the grid, so that they draw grid current, and then the ALC system operates. But and if the bias is too high it'll never get to enough drive, and the drive levels are different for the different bands, so that's what ultimately determines how much ALC you will get for any particular band. Anyhow, rather than showing you the two-tone test signals and things again on the Crow, which you've seen many times before, I'll show the transceiver in operation, and that'll be coming up next.